Welcome to the deep dive. Today we're getting into a massive challenge and, an even bigger opportunity that really sits at the heart of the whole electric vehicle
Mm.
revolution. We're talking about what happens at the end of life for all those huge lithium-ion batteries. I mean, what happens when the EV boom finally meets the reality of waste management?
That is the crucial question. And the answer is driving a really rapid global paradigm shift.
A paradigm shift.
Absolutely. We're moving away from a linear model of, take, make, and dispose.
Mhm.
We're starting to see these old batteries not as waste, but as these incredibly valuable urban mines.
Urban mines, I like that.
They're just so rich in critical materials. We're
Yeah.
talking lithium, cobalt, nickel, all things that are just indispensable for our future.
And we have a fantastic stack of sources today that detail exactly how the world, and especially Europe, is turning this vision into an industrial reality. Our mission is to give you a complete shortcut to understanding it all. We're going to unpack the new, really ambitious regulatory framework from the EU, look at some specific national innovation projects from digital tracking to, believe it or not, microwave ovens, and see how the tech is driving this whole circular economy forward. Okay, let's get into it.
The foundational shift, it really begins with Europe, and specifically with the new EU regulation 2023-1542.
Okay, and this isn't just a minor update, right?
Not at all. This replaces the old directive from 2006, and that distinction is key for you to understand. A directive, well, that just gave member states some leeway in how they implemented the goals.
Sort of like a strong suggestion.
Exactly, but a regulation, that mandates strict, uniform standards across the entire EU bloc. It covers the entire battery life cycle, from production right through to recycling. It just removes all the ambiguity.
Wow. That level of standardization must be a huge industrial commitment. It forces every company in Europe to play by the exact same rules. And our sources point to some deadlines that really change how batteries are made.
They do. And one of the first big milestones is about environmental responsibility. It's the carbon footprint declaration.
So manufacturers have to come clean about their emissions.
Precisely. They have to calculate and publicly declare the CO2 generated during the battery's manufacturing. For EV batteries, this starts phasing in by February 18th, 2025.
So you can't just hide your factory's emissions anymore. The market is going to know exactly how green that battery really is. But what about the materials that go into the battery?
That's where the recycled content minimums become absolutely critical. By August 18, 2028, new batteries, and this includes industrial, EV, and SLI batteries, have to contain minimum percentages of recovered materials.
Hold on, what does SLI stand for?
Good question. SLI is short for starter, lighting, and ignition batteries, the kind you find in regular gas cars. By forcing the use of secondary raw materials, like cobalt, nickel, and especially lithium, the regulation ensures that loop is closed.
Okay, and this next requirement seems like it was born out of pure consumer frustration, designed for circularity.
Oh, absolutely. We've all been there, right? Trying to replace a battery in a device that's just glued shut.
And you just have to buy a new one. It's maddening.
Well, this addresses that exact design flaw. Starting in 2027, batteries have to be easily removable and replaceable. For portable ones, you have to be able to do it yourself.
And for the bigger ones, like in an EV,
For those, it just has to be straightforward for a qualified professional to swap it out. It's a game changer for maintenance and eventually for much more efficient recycling.
so we have rules on construction, content, carbon. But with millions of these batteries coming online, we need total transparency, right?
That's where traceability comes in. The EU is tackling this with two major systems. The first is due diligence.
And what does due diligence actually mean for a battery maker?
It means, starting in August 2025, they have to meticulously track the origin of their raw materials, cobalt, lithium, nickel, graphite, to make sure they're sourced ethically and sustainably.
So it cleans up the supply chain right from the very beginning at the mine.
Exactly. And the second system, which sounds like something from the future, is the digital battery passport.
Okay, tell me about that. A QR code on a battery.
Pretty much. It's required starting February 18, 2027, for all the big batteries. You scan the code, and this digital document pops up. It tracks everything.
Everything.
Chemical composition, the carbon footprint, performance history, and crucially, specific recycling instructions.
How does that actually help a recycler on the factory floor?
It makes the whole system smarter. They scan the code and instantly know the exact chemistry, the state of health, and the best way to take it apart. Before this, they were often just guessing. It boosts efficiency and recovery rates massively.
Which brings us to the final recycling targets themselves.
And they are very ambitious. By the end of 2027, the minimum recycling efficiency is set at 90% for cobalt, copper, and nickel. But the big one is a 50% minimum efficiency for lithium.
And 50% for lithium is hard to do.
It's a huge technical hurdle. It really pushes the limits of what's currently possible at a large commercial scale.
That's an incredible blueprint for a circular economy. Okay, let's shift from the rules in Brussels to the real world to see how a country like Italy is turning this into actual infrastructure.
What's fascinating in Italy is the speed of their response.
Mm.
They didn't wait around. They have already set up their first national value chain, or filiera, for battery recovery.
And this isn't just a small startup.
Not at all. It's a massive consortium of 9 major players. We're talking giants like Cobalt, Enel, and academic leaders like the Politecnico di Milano.
And their first priority isn't even recycling, is it? It's this concept of second life.
Exactly. Or reconversione, as they call it. It's a crucial middle step.
So explain that. How does it work?
Well, think about an EV battery after about 10 years. Its capacity might drop to, say, 80%. That's not great for driving range in a car.
Right, you'd get range anxiety.
But 80% capacity is actually way more than you need for stationary uses. It's perfect for stationary energy storage systems. The buffer energy from solar panels or wind turbines.
So you extend its useful life for another decade, maybe?
Potentially, yes. And we have a fantastic large-scale example of this working right now with Project Pioneer at Fiumicino Airport in Rome.
I saw this in the sources. It's Europe's largest, right?
It is. It's the largest self-consuming storage plant using only second-life batteries. They've integrated over 750 retired modules from 3 different car makers.
And what kind of power are we talking about?
It provides 2.5 megawatts of power and 10 megawatt hours of storage, and it's all integrated with a huge 22 megawatt solar plant on site.
So they're powering a major international airport with old car batteries. What's the environmental payoff?
The projections are massive. Over its first 10 years, the project is expected to avoid over 16,000 tons of CO2 emissions. It just proves that this is a scalable, high-value application.
But I guess this whole second life idea isn't necessary for every single type of battery, is it?
That's an important distinction. For passenger cars, range is everything. But in, say, industrial logistics, think forklifts or cranes, the batteries are often partially charged during breaks and used until they're much more depleted. The need for a standardized second life is less acute there.
Okay, so once that second life is truly over, then we move to actual recycling. What's happening on that front in Italy?
2 major projects are really pushing the envelope. The first is Project Batman.
Batman.
It stands for Battery Treatment and Management. It's Italy's first large-scale hub just for treating lithium and alkaline batteries.
Yeah.
Their goal is to recover up to 95% of the critical materials.
And the second project involves something a little unconventional.
That would be Project Caramel. This is an amazing initiative that uses a specialized industrial microwave oven developed by the University of Brescia.
A microwave oven to recycle batteries.
Yes. The goal is to recover over 90% of the lithium. And what makes it so exciting is the method. The microwaves target just the active material inside the battery.
So you're not just heating up the whole metal casing.
Exactly. It's targeted heating, which cuts energy use by over 50% compared to traditional thermal methods. And maybe more importantly, it eliminates the need for harsh inorganic acids.
Which means less chemical waste to deal with.
Dramatically less. It's just a much cleaner, more sustainable process overall.
So we've seen the EU's regulatory push and Italy's technological build-out. Let's zoom out now and look at the global competition, because one player is already defining the scale of this market: China.
And when you look at the bigger picture, the numbers are, well, they're sobering. China's just operating at a completely different scale.
How different?
The value of China's EV battery recycling market hit an estimated $78 billion this year, in 2024. The recovered materials generated another $90 billion in revenue on top of that.
And the projections are even bigger.
Oh, yeah. They suggest the value of recycled materials alone could top $280 billion by 2030. They have 156 qualified recycling companies, all concentrated geographically, which gives them these incredible economies of scale.
That's a scale that Europe, with its decentralized national systems, would struggle to match quickly.
It's a huge challenge.
Okay, let's dive into the core technology. How are these materials actually recovered? The sources lay out 7 key phases.
It's a very systematic process. It starts with pre-selection sorting batteries by chemistry, then energy recovery and mechanical disassembly. Next is purification to get rid of hazardous stuff. After that, you have liberation and separation of the active materials. And finally, refining everything to a high purity.
And that final refining step is where the big differences are, right? There are two main methods.
That's the critical juncture. The first is pyrometallurgical. It's simple and widespread. You use massive furnaces at incredibly high temperatures, 800 to 1300 degrees Celsius. You basically just melt everything down.
So high energy use. What's the downside?
Well, it's good for recovering things like copper and cobalt as alloys, but it's so hot that a lot of the valuable lithium is just burned off or lost in the slag. You lose one of the most critical elements.
So that brings us to the more modern alternative.
The preferred route for sustainability, yes. That's hydrometallurgical refining. It uses low temperatures and aqueous chemical solutions to selectively dissolve and separate materials.
Almost like a chemical bath.
That's a good way to think of it.
Mm.
It's far more selective, uses less energy, and can achieve really high purity. We're talking nearly 100% recovery of lithium and cobalt sometimes.
But the chemicals must create their own challenges.
They do. It's more complex, and you have to carefully manage the chemical waste. But its potential for maximizing lithium recovery is just so much higher.
And this is where the future of recycling gets really interesting. The ultimate goal is to skip that heavy refining altogether.
That's the push toward direct recycling. See, right now, most processes create this black mass, a messy slurry of crushed materials that then has to be refined. Direct recycling aims to skip that step.
And how would that work?
It works by preserving the structure of the active materials so they can be reused immediately, but it relies entirely on two things. First, batteries that are explicitly designed for recycling. Second, enhanced traceability, like with the digital passport. If recyclers know the exact chemistry and the remaining state of health, they can process it gently and keep the materials viable for direct reuse.
So wrapping this all up, what does this mean for you, the listener?
I think the shift we're seeing is truly transformative. We're moving EV batteries from a future waste crisis into a necessary, strategic national asset. This circular economy is crucial for Europe's sustainability goals and maybe even more for its long-term supply chain independence.
Right. That regulatory framework from Brussels with the passports and deadlines is clearly an attempt to build that independence by design. But the sheer scale of the Chinese market, not just in making batteries, but now in recycling them, raises a pretty significant question for Europe.
And that question really is, will these advanced, transparent, and ethical supply chains being built in Europe, will they scale up fast enough to meet future demand?
Or will Europe end up dependent on recycled materials that are processed elsewhere, which kind of undermines the whole strategic goal?
That tension between speed and sustainability, between independence and reality, that's the key challenge going forward.
We hope this deep dive has provided you with a clear understanding of the evolving landscape of battery recycling, from the far-reaching mandates in Brussels to the microwave innovations in Italy. Thank you for tuning in and sharing this learning journey with us. Be sure to follow our channel for more deep dives into complex, fascinating topics.